Hello, my dear students. In last class, we were discussing about how we can estimate a distributed lag model. And so far, we discussed two different types of method, starting from ad hoc oilless procedure and a Koyck model. Okay, and when we discuss about a mind map of all the estimation technique available, we were discussed that this Koyck model is purely an algebraic model. Okay, that is mean by that is what does it mean that there is no any theoretical base for the mathematical manipulation that is done by Mr. Koyck. Koyck has finally agreed or finally arrived at an equations without any theoretical background. Okay, by taking some deviations or by taking the lagged values, multiplying all this equation with a constant lambda. Okay, he arrived at an equation. That equation is a autoregressive model, and we can directly apply Euler's to this transformed equation of Koyck. That was the idea behind the Koyck model. But the main problem with this Koyck model is it is theoretically not supportive. There is no any theory to support this Koyck model. Okay. Subsequent to this Koyck model, in macroeconomic as well as in microeconomics, some theory has developed. Okay, and this theories was in line with, or the empirical verification of this theory was in line with the Koyck model. Okay, so two different theoretical model was evolved. One is the adaptive expectation model, and you might have learned this model in your macroeconomic class. And the other one is the partial adjustment model. Okay, or you might have learned in your microeconomics about this partial adjustment model of Nerlov. Okay, so we will discuss these two models in detail. Okay, so starting from the adaptive expectation model, the adaptive expectation model is a theoretical rationalization of the these Koyck models. Okay, so the most important limitation of Koyck model is it is a purely algebraic model and it's not based on any theoretical support. Okay, so the adaptive expectation model is one way of rationalizing the Koyck model with theoretical support. Okay, so adaptive expectation model is not a different method but a method that will rationalize this Koyck model. Okay, yes. So, for explaining this model, let me take an example. Yt is equal to beta 0 plus beta 1 x star t plus error terms. You might have learned this equation or you might have studied this equation in your macroeconomic classes when we discuss about this demand for money. Okay, so what is this Yt? Yt is nothing but demand for money or demand for real cash balance. Okay, then this x star t is nothing but the expected rate of interest rate. Okay, or long run interest rate or optimum interest rate or equilibrium interest rate. So most commonly we use the term long run or expected interest rate. Demand for money is a function of expected interest rate. Okay, so what this equation says, this equation says that the demand for money is a function of expected interest rate. Okay, yes. And the main problem with this theory is that this expected interest rate, how we can find out this expected interest rate? Current interest rate we can easily find out. If you look at this, the central bank website, some central banks uh, introductions or central banks reviews, we can learn about this current interest rate. But the demand for money is not depends on current interest rate, but it depends on the expected interest rate. Okay, so how you will observe the expected interest rate? Okay, so this type of a similar problem will arise when you will learn about this expected inflation. Okay, so we know how to calculate the inflation, current inflation, but we don't know how to calculate the expected inflation. Okay, so the expected inflation is not directly observable. Similarly, expected interest rate is also not directly observable. So what we do here, a hypothesis is coming to analysis. What is this hypothesis? It is called adaptive expectation hypothesis. What is this adaptive expectation hypothesis? You all of you know that what is the adaptive expectation hypothesis. Okay, so this hypothesis is telling about how the people make their expectations about the economic variables. We have a lots of economic variables: GDP, money supply, inflation, interest rate. Okay, and people are making some expectation about all these variables. What will be the expected growth rates? What will be the expected interest rate? What will be the expected inflation? Okay, what will be the expected money supply growth? What will be the expected index of industrial production or industrial growth rate? What will be the expected agricultural growth rates? Okay, so people are making some expectation about these things. Okay, so the adaptive expectation model or hypothesis is an hypothesis about how the people are making some expectation about the future economic variables. Okay, so this hypothesis says that people make their hypothesis expectations about what will happen in the future based on what happened in the past. Okay, so people make the expectation about what will happen in the future based on what is happening in the past. Okay, it means that people will form their expectation about the future based on their past experience. Okay, and they will learn from their mistake also. They are not only make some expectation about the future, but they will learn from their mistakes. Okay, for example, let me take an example. One day, all of a sudden, a rain comes. Okay, and many of us will not take the umbrella. Okay, so when you are coming to college, you are not taking umbrella. So what happened that due to heavy rains, you got stuck in the rain. You could not go to home on the time. Okay, so finally you arrive at your home. The next day, will you take the umbrella? Majority of you will not take the umbrella because yes, we are expecting that yesterday we had rain due to some unexpected things or some unexpected changes in this climate. Yesterday we had a rain, but the rain will not come today. Many of you, the 99% of you will not take the umbrella. You came to college. This day also you got stuck in rain. Okay, so tomorrow what will happen? You have you will make some expectation about the rain based on your past experience as well as the the error that you have committed in the past. Yesterday you have committed one mistake. What that mistake? You didn't take the umbrella, you stuck in the rain. Okay? And yesterday and day before yesterday you had an experience that unexpected rains. Okay? So yesterday and day before we had an unexpected rains, and you are expecting that this unexpected rain will continue today also. And this you have learned not only from your past experience but also from your past mistake. Okay, so this is the idea behind the adaptive expectations. Okay, what is this hypothesis? People will learn from past experience. Sorry, people form their expectation about the future economic variable based on the past experience, and they also learn from the previous mistakes or mistake they have committed. Okay, so this is the main idea behind this adaptive expectation hypothesis. So this hypothesis we can express mathematically using an equation. What are these equations? This equation says that uh, yeah, x star t. What is x star t? Expected interest rate minus previous expected interest rate is equal to a coefficient gamma into actual interest rate minus previous expected interest rate. What is this equation? X star t is equal to, x star t means expected interest rate, x star t minus 1 previous expected interest rate is equal to a gamma coefficient of xt means current interest rate minus expected previous expected interest rate. Okay, so we will come to this equation later. Okay, so for time being this gamma coefficient is known as the coefficient of expectations. Okay, so this coefficient of expectation will always lies in between 0 and 1. Okay, and this hypothesis was popularized by Kagan and Friedman, and this hypothesis is popularly is known as adaptive expectation hypothesis or progressive hypothesis or error learning hypothesis. Okay, now what this equation says, what is this x star t minus x star t minus 1 is equal to gamma xt minus x star t minus 1? This equation says that the the expectations are revised in each period by a fraction gamma of the gap between the rate of interest observed in the current period and its previous expected interest rate. Okay, so in each and every day we will make, in your rain example, in each day you will make some changes or you will revise your expectations. Okay, so the gamma coefficient is what? Your expectation coefficient. This will be revised in each day. Okay, and now in our example, okay, in each we will revise our expectation in each period by a fraction of gamma of the gap between xt and xt star minus 1. Okay, so you will be we will be revised our expectation about this future economy variable about actual value and its previous expected value. Okay, so this is the main equation. This is the what is called adaptive expectation hypothesis or adaptive expectation equation. Okay, now what will happen? You just multiply this gamma. What you do is you multiply this gamma into xt and gamma into xt minus 1. What you will get? Okay, what you will get me, uh, x star t is equal to, this x star t is equal to gamma xt minus gamma xt minus xt star minus 1. Okay, this minus x star t minus 1 will come to the right hand side, so it will be plus x star t minus 1. Okay, yes. Now uh, if you look at this, x star t is equal to gamma xt plus, okay, I am bringing this value to the into front, x star t minus 1 minus gamma x star t minus 1. Okay, and x star t is equal to gamma xt plus, okay, what is the coefficient of this xt star minus 1? Look at this, this is x star t minus 1, this is also x star t minus 1. Okay, this is x star t minus 1, this is also x star t minus 1, there are two x star t minus 1, you take it as a common. Okay, we have taken it as a common. Now this this variable coefficient is gamma, this coefficient variable is nil, that means it is 1. Okay, so this coefficient is 1, so 1 minus gamma, then common value is x star t minus 1. Okay, so what we have done now, we have converted our adaptive expectancy hypothesis into a new equation. Now what does it mean? Now the equation shows that the expected interest rate is a weighted average of actual interest rate and its previous expected interest rate with a weight gamma and 1 minus gamma. You look at this, this is x star t. What is that? Expected interest rate, which is equal to gamma xt. Xt means what? Current interest rate multiplied by your expression coefficient plus 1 minus gamma into previous expected interest rate. So now the expected interest rate is a weighted average of actual interest rate with a gamma coefficient, gamma weight, and x star t minus 1 with a 1 minus gamma weight. You got the point? Yes. Now what will happen to these equations when your expectation is equal to 1? Okay, that means if your expectation is exactly correct, what will happen? You look at, if your expectation is equal to 1, okay, so this will be 1 into xt minus 1, okay, plus 1 minus 1 xt minus 1, so all this term will goes. Okay, so what will happen? X star t will be equal to xt. If your gamma coefficient is equal to 1, then your current interest rate will be equal to your expected interest rate. Okay, or if your gamma coefficient is 0, what does it mean? Okay, your x star t will be equal to x star t minus 1. This will be, this coefficient will go, because this will be 0, 0 into xt is 0, 1 minus 0, it is equal to 1, 1 into x star t minus 1, x star t minus 1. Okay, so x star t will be equal to x star t minus, I mean your future expected interest rate will be equal to your previous expected interest rate. Okay, yes. Now suppose if you give some value to this x star t, xt, and x star t minus 1, suppose assume that we are expecting that the interest rate will be 8%. Now the actual interest rate is 10%. We previously expected 7%. You look at, we expected 7% in the previous period, but it was wrong. What happened? Current interest rate is 10. Okay, and now what we are expecting, we are expecting that in the future it will be 8%. Okay, so as you give some suppose if gamma is equal to 1, what will happen? 8 is equal to x star t. 8 is equal to 1 into 10 plus 1 minus 1 into 7. It is equal to 8 is equal to 10. What is 8? 8 is equal to expected interest rate. What is 8 is equal to 10 means what? 10 is equal to x star t. That means your expected interest rate will be equal to your current interest rate. Okay, and if you give 0 for gamma, then what will happen? X star t will be equal to x star t minus what? Expected interest rate will be equal to the previous expected interest rate. Okay, now we are going to derive the model. What you have to do is substitute the adaptive expectation model or equation in the original equations. Okay, so what was our original equation? Nothing but yt is equal to beta 0 plus beta 1 x star t plus ut. X star t is not directly observable, so we have adopted this adaptive expectation hypothesis. Now you substitute the equation of this your adaptive expectation model in here. So what will be the equation? You look at this is the adaptive expectation model, the adaptive expectation equation, gamma xt plus 1 minus gamma xt minus x star t minus 1. Okay, now we have substituted this equation into the original equations. Now what will happen? Yt is equal to beta 0 plus beta 1 gamma xt plus beta 1 1 minus gamma xt minus 1 plus ut. We have substituted our adaptive expectation equation into our original equation. Okay, now you take the one period lag of this original equations. You take the one period lag of your original equation. What was our original equation? Original equation was yt is equal to beta 0 plus beta 1 x star t plus ut. You take the one period lag. What will happen? Yt will become yt minus 1. Beta 0 will be there, beta 1 will be there, x star t will become x star t minus 1, and ut will become ut minus 1. This is what is called one period lag of your original equation. Okay, now you multiply this equation with 1 minus gamma. Okay, so 1 minus gamma into yt minus 1. Okay, then 1 minus gamma into beta 0 plus 1 minus gamma into beta 1 x star t minus 1, 1 minus gamma into ut minus 1. Okay, now 1 minus gamma yt minus 1 is equal to, here 1 is there, beta 0 is there, 1 into beta 0 will be beta 0 minus gamma beta 0 will become minus gamma beta 0 plus 1 minus gamma beta 1 x star t minus 1 plus 1 minus gamma ut minus 1. Now what you have to do is subtract the above equation from your this equations. This is the yt. You subtract 1 minus gamma yt minus 1 plus this equation. What will happen? We will see it. Okay, this is yt. This is 1 minus gamma yt minus 1. You subtract it. Nothing but you write two equations, then you are going to subtract one equation from another equations. Okay, so yt minus, so it will be yt minus 1 minus gamma yt minus 1 will be equal to, this is the yt, this is the yt minus 1. What will happen here? You look at the two equation, many terms are similar. This is the plus beta, this is plus beta 0, this is minus beta 0. This beta 0 and this beta 0 will be cancelled. Okay, then the remaining intercept is gamma beta 0 here and beta 1 or beta 1 gamma xt here. Okay, so this will be our intercept, gamma beta 0 plus beta 1 gamma xt, or gamma beta 1 xt, both are same. Okay, now this term will be cancelled out and this term will be cancelled out, because this will be negative and this will be positive. Okay, and this is the ut and this is the ut 1 minus gamma ut minus 1. So our error term will become ut minus 1 minus gamma ut minus 1. Okay, now this is yt minus 1 minus gamma yt minus 1. Okay, you bring this term into the right hand side. So what will happen? Yt is equal to gamma beta 0 gamma beta 1 xt plus, this is negative, will become plus 1 minus gamma yt minus 1 plus vt. Vt means nothing but this total error terms, this total error terms. Okay, so this is the equation for the adaptive expectation model, or the the uh, the uh, the demand for money equation using the adaptive expectation model. Okay, so in this model our intercept is equal to gamma beta 0. Okay, then first the immediate impact is equal to gamma beta 1 xt. Okay, then we are including the past values of your dependent variable with a coefficient minus 1 with a coefficient 1 minus gamma. Okay, now you just see the difference between two models. This was our original equations. Yt is equal to beta 0 plus beta 1 x t plus ut. What was the problem with these equations? We cannot directly observe this x t. So what we have done, we have observed this x t using adaptive expectation model, and we have converted this equation into another equations. Now you will look at this. What's the equations? Now we don't have the expected coefficient. We are all having the current coefficient. Okay, because this coefficient we have observed using the adaptive expectation model, and we have converted our this equation into this equation. Okay, so in the first equation, what beta 1 will measure? Average response of y to a unit change in x star t. What will be the value? How much value will be changed? How much y value will be changed when your expected interest rate will change? But now you look at the second equation. What this gamma beta 1 will measure? It is what will be the average changes in y. That means what will be the changes in your demand for money when your actual interest rate changes. Okay, actual interest rate is not a problem, it can be directly observed. Okay, so now what we have done is we have changed our a model into a model which is unobservable into an observable model using the adaptive expectation hypothesis. Okay, yes. Now in practice we cannot find out the first equations. Okay, but once we estimate the second equations, okay, we can easily compute beta 1 by simply dividing the coefficient of xt. Okay, so you look at this equation, first equation. Suppose if you want to find out this value beta 1, you don't have values on x star t because x star t is not available. So what you have to find out beta 1 where the data for x star t is not available. So what you will do? You will estimate these equations, and here you have this xt and yt minus 1, both values are available. Okay, and if you regress this yt on xt and yt, you will get intercept. This intercept will be gamma beta 0, and you will be get a slope coefficient for this xt, and this slope coefficient will be a multiple of gamma and beta 1. Okay, and the coefficient of yt minus 1 will be 1 minus gamma. Okay, so once you find out the gamma coefficient from these equations, we can easily find out the value of your beta 1. Okay, yes, yes. So now you look at this two model, Koyck model and adaptive expectation model. Both are looking the similar. If you look at this both model, earlier we have used the lambda coefficient, but here we are using the gamma coefficients. Okay, and if you compare both model, you can see that both models are autoregressive model. Okay, when we started the model, it was a distributed lag model, but when we derive the final equation, it is becoming an autoregressive models, and both models are looking like the same. Yt is equal to a intercept plus a slope coefficient, and xt plus yt minus 1 plus n error terms. If both equations are same. Okay, but the differences is there only in interpretations. The interpretation will be different. Okay, yes. So in the next video or in the next lecture, we will see how we can do the adaptive expectation model practically. Okay, yes. Thank you.